everyone. I am Aditi Arora from ABES Engineering College, Ghaziabad. In today's video lecture, we will be covering the disadvantages of semaphores from the unit 2, that is process synchronization, subject, operating system. So in the last lecture, we discussed about the concept of semaphores, that semaphores are basically a software-based solution for the critical section problem. And semaphore can be implemented with two atomic operations, that is wait and signal operation. Through wait operation, the process gets the access to critical section, and when a process completes its dedicated task in the critical section, it releases the critical section using the signal atomic operation. And then now, also we discussed about the two types of semaphores, that is binary semaphore and the counting semaphores. Now, in this lecture, we will discuss about the major disadvantage of semaphore, that is busy waiting. So the most important disadvantage of semaphores is busy waiting. Now, what is the meaning of busy waiting? If you remember, we have seen the code for wait operation. That was something like this. We have a semaphore S and we are applying the wait operation on this semaphore. And in this code, we were checking whether the value of semaphore is less than equal to 0 or it is greater than equal to 0, right? So whenever a process tries to enter the critical section, then if the value of the semaphore S is greater than 0, then process can enter the critical section. And once it gets its execution done in the critical section, it again increment the semaphore value using the signal operation, right? So whenever one process, say for example, P1 is in the critical section, process P1 is accessing the critical section, at this time, if some other process tries to execute in the critical section, then while condition for that process will always be true. He will get the value of S as 0 or less than 0. So that scenario is called as busy waiting, that the particular process P2, say for example, is continuously looping in this while loop, because continuously he is getting this condition as true and he is unable to enter into the critical section. Why? Because P1 is already executing in its critical section. So the major disadvantage of semaphore is busy waiting. Busy waiting means that while a process is in its critical section, then any other process that tries to enter the critical section must loop continuously in the entry code. Now, how busy waiting is a kind of a problem in the semaphores? So busy waiting basically wastes the CPU cycles that can be utilized by some other process for some productive work, right? When process P2 is continuously coming and checking this while condition as true, this means this process P2 is actually wasting the CPU cycles every time it checks or it tests this while condition. So this kind of semaphore are also named as spin lock, because the process spins while waiting for the lock to get into the critical section. Now, we can provide a solution to this busy waiting problem that comes under semaphores. We can little bit modify the definition of the wait operation and the signal operation, right? So when a process executes the wait operation and find that the semaphore value is not positive, then it must wait in the while condition, right? While condition, जब तक process को true मिलेगी, तब तक वो while condition में ही spin करता रहेगा और वो wait करता रहेगा. So what solution can we have? So rather than engaging in the busy waiting, means process जो है वो continuously while condition में ही spin ना करता रहे, हम क्या कर सकते हैं? Process को block कर सकते हैं, right? प्रोसेस को ब्लॉक करने से क्या होगा, हम उसे एक वेटिंग क्यू में जो है वो इंसर्ट कर देंगे और उसकी स्टेट को चेंज कर देंगे इनटू अ वेटिंग स्टेट। अब प्रोसेस जो है व्हाइल लूप पर बार बार स्पिन ना करते हुए वो एक क्यू में रहेगा एंड दैट क्यू इज कॉल्ड एज द वेटिंग क्यू, और वहां पर उस प्रोसेस की स्टेट हो जाएगी वेटिंग स्टेट। सो इंस्टेड ऑफ spinning at the while condition, now the process will be in the waiting state, in the waiting queue. Now जो पहले CPU cycles waste हो रही थी, that can be prevented and the control is again transferred to CPU scheduler, which can select any other process to execute productively. So one of the basic solution to prevent busy waiting is to implement the semaphores along with the waiting queue. But this also leads to a problem called as deadlock and starvation. See, here we have two processes, P0 and P1, and these processes are using two semaphores. One is S and other one is Q. So first of all, say for example, process P0 has accessed or executed wait operation on the semaphore S, and at the same time process P1 is acquiring the semaphore Q using the wait operation, right? Now in the next instruction, process P0 wants to access the semaphore Q, means it wants to acquire lock using the semaphore Q, but the process P0 will not be able to come out of this wait condition. It will remain true for P0 because Q semaphore is already occupied by process P1. So process P0 is waiting for process P1 to release the Q semaphore after completing its execution in the critical section. And in the second instruction, process P1 wants to have the lock on semaphore S using the wait operation, but process P1 is unable to do so. This condition will be true for process P1, and process P1 will keep on looping in this while condition because semaphore S is already being acquired by the P0 operation. So here what we can see is process P0 and P1 are depending upon each other to release any one of the semaphore that are being acquired by them in the first instructions. So now process P0 cannot execute the signal instruction because process P0 is stuck here in the second instruction, that is wait Q, which is always true for process P0. Also, process P1 is not able to release the Q semaphore because process P1 is stuck here in the second instruction and he is unable to acquire the lock on semaphore S. So in this way, we can say that this situation leads to deadlock because no one of these two processes are able to progress and access the other semaphore that they require. So this situation is called as deadlock and starvation, means it may be possible that these two processes can lead to indefinite waiting for the Q as well as the S semaphore, what they need. So this is called as deadlock and starvation. So the conclusion is that the conclusion of this lecture is that we have studied semaphores, which are a software-based solution to critical section problem, and they help us to achieve process synchronization in multiprocessing environment. And semaphores can be operated through two atomic operations, that is wait and signal. And the major disadvantage of semaphores is busy waiting, means the process which for which the while condition is always true is continuously looping around this while condition, spinning in this while condition. This scenario is called as busy waiting. We tried to modify the code of wait and signal operation to resolve the problem of busy waiting, but still we came across two more problems, that is deadlock and starvation. These are the references from where we have prepared the content. Thank you.